All right, so I'm going to go over section 2.5. We're going to be solving literal equations in this section. So everything up until now, so 2.1 to 2.4 is about solving equations and getting a number. In these problems, we'll solve an equation for a variable with respect to other variables. Now you're going to see what that means with the next few slides, and we're going to do some examples. All right, so the objectives here, we're going to solve a formula for a given variable, and we're going to solve an equation in two or more variables for one of the variables. So again, you're going to see something with an expression. It's not going to be a whole number as an answer or an integer or fraction, whatever. You're not going to get a number as an answer, but you're going to get a kind of formula as an answer. All right, so hopefully we know what a formula is. We've seen formulas for hopefully as long as you can remember doing math. So it's an equation that states a rule for a relationship among quantities. So something like this one, in the formula D equals RT, D is isolated, right? Meaning it's by itself on this side of the equal sign. All right, so think of the equal sign. I tell you guys in class, think of the equal sign like two sides of a scale, right? So that's why I draw these little dotted lines, or I just draw a line through it, right? On this side of the equal sign, there's just a D. On the other side of the equal sign, you have more variables. You have an R and a T. The D is isolated. So you can rearrange a formula to isolate any variable by using inverse operations, and this is solving for a variable. All right, now a formula is a type of literal equation, and it says here a literal equation is an equation with two or more variables. To solve for one of the variables, use inverse operations, right? Just like in the previous slide, it said to solve for a variable. Again, you're going to use inverse operations. You're going to see what operations are being done to the variable in question, and then you want to do the opposite of it to kind of get it. You want to get it by itself, isolated. All right, so that's kind of what I just said in step form, right? So the first step, you want to locate the variable you're asked to solve for. The second step, you want to identify the operations and the order in which they are applied. And then the third step, you want to use inverse operations to undo the operations and isolate the variable. And we're going to do that in a couple of examples. All right, so the rest of these slides are just examples, right? So everything from here forward is just going to be us working through some problems. All right, A and B on this slide are some of the easier examples, right? These are able to be done in one step. Now you're given a formula, right, or a kind of literal equation, right? We had just said a literal equation is a formula is a kind of literal equation, right? Because we have two variables here. We have an x and we have a y, right? Now we want to solve x plus y equals 15 for x, right? So let's locate our x. In this example, it's highlighted in, or it's written in blue for us, right? So this is our x. Now on this side of the equal sign, right? So the side of the equal sign with the x, what is being done to the x, right? You see that there is a plus y on this side of the equal sign with the x, right? And that's the only thing being done to the x on this side of the equal sign. So you want to do the opposite of adding y to get the x by itself, right? In all of these, you want, right? If it says you're solving it for x, you want x equals something, right? Now to get x equals something, you need it by itself. We want to subtract y on both sides of the equation, right? That's another reason why I like splitting it up, splitting up the equal sign, because some kids like to write, okay, minus y here and then maybe minus y on this x, right? It goes only one time on each side of the equal sign, or each side of this line that you draw. All right, so let me erase that. So as of right now, we have x equals 15 minus y. All right, and we have our x equals, right? So this is our answer. All right, because on this side, y minus y goes away, and then 15 minus y, you can't combine these, right? These are not like terms, so you leave it alone. And then this is our answer. All right, now let's look at the second one. Solve PQ equals X for Q. All right, again, on this side of the equal sign, so I'll split up the equal sign. Which side is Q on? It's going to be on your left, right? And it's already colored in blue for you, right? So this is the variable that we want to solve for. We want this by itself, right? So we have PQ equals X. This is the same as P times Q equals X, right? So to get that Q by itself, the opposite of multiplying P is dividing by P. So let's divide both sides by P. And then P divided by P goes away, right? Because that just becomes 1. And then we get Q equals X divided by P. All right, and then there's our equation solved for P, or for Q, I'm sorry. All right, now we want to solve 5 minus B equals 2t. We want to solve it for t. All right, so now on this side of the equal sign, we have our t, right? So on this side, right? So we have 2 times t on this side, right? So we located the variable, we identified the operations, right? So it's t is our variable and 2 times multiplying is our operation. So then the opposite of multiplying by 2 is dividing by 2. So then we want to divide both sides by 2. So let's divide this entire thing by 2, right? The whole thing, right? Not just the 5, not just the b, everything by 2. So then we have 5 minus b divided by 2 equals t, right? And there's our answer, right? So I don't care that it's on this side of the equation, right? You could have also written t equals 5 minus b over 2, right? That's the exact same thing, right? There's no difference between them. All right. So here's something that you maybe have seen before in middle school, right? If you don't remember it, you're going to see it a lot more in geometry. But this is the formula for the circumference of a circle in terms of the diameter d, right? So the circumference of the circle they gave us as the letter c, and the diameter is d. So we want to solve in terms of d, the diameter. Let's say we're given a circumference, right? We want to be able to find the diameter, right? So first step we want to do is locate the variable, right? Our variable is d, right? And now we want to identify what operations are being done to it, right? So on this side of the equal sign, right, with the d, what operation or what's happening with that pi and that d? What's that pi doing to the d, right? It's multiplying it, right? So we want to get rid of something that's being multiplied by dividing, right? So let's divide by pi on both sides. All right, and then pi divided by pi cancels out. So then we get c divided by pi equals d. All right, and then we have our d equals, right? If it says solve in terms of d, we want d equals something, right? And we have it here, right? So this is our answer. All right. And now this is the equation that we had seen in the very beginning, or the formula that we had seen, right? We want to solve this formula, d equals rt, for t, right? First thing we want to do, identify the variable. It's going to be t, right? Now we want to identify the operations that are being done to it. So what's happening to the t? It's being multiplied by r, right? So r times t. And how do you get rid of r times? Is divide by r on both sides. All right, so we get d over r equals t. All right, so now we have the formula for the area of a triangle. Again, you maybe seen this before, right? Now, let's say we're not given a base, we're not given a height. Let's say we're given the area and we're given the base, and we want to solve for the height of a triangle, right? So we want to get the h by itself, right? So we've identified our variable, it's h. Now what operations are being done to it? It's being multiplied by b, and it's being multiplied by a half, right? So we could do this all in one step, but I'm not a fan of dividing by fractions, right? So you could divide 1/2 b on both sides, but I'm not a fan of dividing by fractions, and I don't imagine you guys are either, right? So what we can do instead is let's get rid of 1/2 the only way we know how, right? What do we need to multiply 1/2 by to get it to turn into a 1 in identity, right? We want to multiply it by the reciprocal, right? So 2/1, right? So let's multiply both sides by 2/1. Both sides of the equal sign, right? And then 2 and 2 cancel out, 1 and 1 cancel out. And then 2 divided by 1 is just 2. And then 2 times a is just 2a. Right, so anything divided by 1 is itself. So 2 times a we can just write as 2a. So far we have 2a equals b divided by h. All right, the next thing we want to do is get rid of that b, right, to get h by itself. All right, so if we have b times h, to get rid of b times is divide by b. So let's divide both sides by b, and then b and b go away. And then on the other side of the equation, we have 2a divided by b equals h, right? And we have h by itself, right? Is it by itself? Is it the only thing on this side of the equal sign? Yes, it is, right? So this is our final answer, right? H equals 2a over b, or 2a over b equals h, right? Again, the order doesn't matter. You could also write as h equals 2a over b. All right, that's fine too. All right, so let's try some more examples, right, that maybe require a little bit more steps, right? So in this equation, we want to solve this literal equation for y, right? So far we have 3y plus 4x equals 9, right? So first identify the variable. Again, it's colored in blue for you. All right, now you want to identify what operations are being done to this y, right? It's being multiplied by 3, and it's adding, and 4x is being added to it, right? You notice that this 4x doesn't have anything to do with that y. It's just being added to it, right? So the first thing that's being done is it's being multiplied by 3, and then 4x is added to it, right? So let's do our inverse operations, and let's do order of operations backwards, right? So let's take care of any addition and subtraction first. All right, so let's subtract 4x on both sides. All right, so far we have 3y, and then 4x minus 4x goes away. All right, and then equals 9 minus 4x. All right, and then is the y by itself? All right, we're getting closer, but it's not quite by itself. It's 3 times y. All right, so how do you get rid of 3 times? Is divide by 3. All right, and then 3 divided by 3 goes away. So then you get y equals 9 minus 4x divided by 3. All right, and now from here, what we can do is we can split it up. Right, so if a fraction has 2 terms on top, but only one denominator, you can split them up to be 2 different fractions, right? So we get y equals 9 divided by 3 minus 4x divided by 3. All right, and then 9 divided by 3, hopefully we know what that is. Right, that's just going to get us y equals 3. And then 4 and 3, you can't simplify that, right? They don't have any common factors. So you just leave it alone. So we just get 3 minus 4x over 3. All right. And there's our final answer. All right, so these ones may be a little bit harder, right? So some of them require multiple steps, right? So something like this one, we want to solve this literal equation for x, right? We want to first we want to identify where the x is, right? There's an x right here, and there's another one here, right? There's 2 of them, right? When there's 2 of them, you can't really combine them. Right, these aren't like terms, so we can't just do 3 plus 5, right, because this one has a z with it, right, so these are not like terms, All right, but there's two x's. How do you just get one x out of it? Well, if you notice, this x is being multiplied to both of these terms. Right, so if it's being multiplied to both of these terms, that's the same as if we were to say x times our terms. So x times 3 plus 5z is what's going to get us this, right? So what we have here, right, let me see if I can highlight it. Right, so what we have here is exactly the same as what we have here. Right, and if you don't believe me, you can verify it, right? So you can distribute x, right, and then you get x times 3, right? You don't have to write this, but it's going to be 3x, and then x times 5z is going to be 5zx, right? But if you remember a commutative property of multiplication, we're allowed to switch the order of these, right? So we get 3x plus 5xz, right? And this is exactly what we have here. All right, so hopefully we're all okay with that, right? You're allowed to pull out an x as a factor, right? Because this x, when you distribute it, you get this, all right? Now, once you do that, what is happening to this x? Like, what's the operation that's happening to it? It's being multiplied by this entire expression here by 3 plus 5z, right? So we want to get rid of something that's being multiplied by dividing. So let's divide both sides by 3 plus 5z. Right, so divide both sides by 3 plus 5z. All right, now it's not the prettiest thing, right? But when you divide it by itself, it cancels out. So we still get our x equals y divided by 3 plus 5z. All right, and there's your answer. All right, so a couple more steps for this one, right? We had to kind of do distributive property in reverse. All right, so this is distributive property backwards. All right, we kind of did distributive, yeah. Property backwards. Right, typically we do PEMDAS backwards, right? But this is kind of part of that process, right? All right, so let's keep going. This also might be something that you've seen before, maybe from middle school, right? So this is the formula for the surface area of a rectangular prism, right? So it's S, which is our surface area, is equal to 2 times the length times the width, plus 2 times the length times the height, plus 2 times the width times the height. All right, so we want to solve this formula for L, right? We want to solve it for the length L, right? Same process as always, we want to identify our variable, right? It's going to be this L and this L right here, right? Again, there's two of them. So we're going to do something similar like we did to the last one. But first, we have another kind of straggler over here that doesn't have an L but is still on this side of the equal sign, right? So on this equal sign is going to divide the section into two parts, or divide this equation into two parts. Right, so let's get rid of this plus 2wh, right? This is being added to this equation and has nothing to do with this L. Right, so let's go ahead and subtract it. Let's subtract 2wh on both sides of the equal sign. And then 2wh minus 2wh goes away. And then you get s minus 2wh equals, and then we're left with 2lw plus 2lh. All right, and now the only thing that we have on the right side of the equal sign are terms that have an L. So again, we have an L here and an L here, right? And this L, or these L's, are being multiplied to 2w and 2h, right? So we can do something similar like we did to the last one. Why don't we do reverse distributive property, right? So let's take out the L, and then you're left with 2w plus 2h. Again, if you're ever unsure, what happens when you distribute L to everything, right? You should get this same expression. All right, so we get L times 2W plus 2H, and this equals S minus 2WH. All right. And the last thing we have to do, right, this L is being multiplied by 2W plus 2H, right? So we want to divide both sides by whatever is being multiplied. So divide 2W plus 2H on both sides. All right, and then when you divide by itself, it goes away. And then on the other side of the equal sign, we have S minus 2WH divided by 2W plus 2H. And this is equal to L. We have our L by itself on this side of the equal sign. All right, so we get this as our final answer. All right, just one more for today. And this one is a temperature formula. So again, maybe something that you've seen before, middle school science, right? We want to solve, let's say we're trying to convert from Fahrenheit to Celsius, right? So this is an equation. We're given something in Fahrenheit, right? So let's say we have a temperature of like 60, 70 degrees, right? If you have 70 degrees, all you have to do is plug in 70 and for F, solve this equation, and then you should get an answer for degrees Celsius, right? But let's say you're traveling, right? You're in another country, right? And you want to find the temperature in a way that you can understand it. Maybe you're used to Fahrenheit, but this country uses Celsius, right? So we want to convert this formula into an equation that has F equals something, right? So let's see what's happening on this equation, right? So our variable right now, right, let me get rid of that 70. That was just an example, right? Our variable that we're solving for is F, all right? Now we want to see what operations are being done to F and in what order, right? So we're subtracting a 32, right? But it looks like the last thing that was done to this equation was multiplying 5 over 9, right? So let's get rid of that 5 over 9, right? We did an example like this kind of earlier in this video, right? To get rid of a fraction that's being multiplied, you want to multiply by its reciprocal. So let's multiply by 9 over 5 on both sides, all right? And then 9 and 9 cancel out, 5 and 5 cancel out, all right? And then the only thing that you're left with is F minus 32, and then this equals 9 over 5c, right? Now the last thing we want to do is we want to add this 32, right? That's the only other operation that's being done with the F, or to the F, right? So we get plus 32, because minus 32 plus 32 goes away. Then we get F equals 9 over 5c plus 32. All right, and again, it could be in any order. So the way that we solved it now, we got 9 over 5c plus 32 equals F, right, with the F on the other side, on the right side. It doesn't matter. It really doesn't matter. All right, but now let's say, right, so this is our equation for when we're given Fahrenheit, or no, when we're giving Celsius, we want to convert it to Fahrenheit. Let's say you're in a country and it's 30 degrees Celsius. So let's say it's 30 degrees Celsius, right? And this is our temperature in Celsius. And we want to find the temperature in Fahrenheit, right? So if you're not familiar with Celsius, but in the United States, we're pretty familiar with Fahrenheit, you would want to be able to understand what temperature this is, right? To understand kind of how to prepare for this kind of weather. Let's say you're traveling somewhere, right? So 30 degrees Celsius, you would want to plug that into this formula here, right? And then you get 9 over 5 times 30 plus 32, all right? And then you want to solve this, right? So multiplying fractions and whole numbers, we can simplify 30 and 5, right? 30 is the same as 30 divided by 1, right? So we can cross cancel here, right? If 9 over 5 is being multiplied to 30 over 1, right? 9 over 5 can't simplify, but 5 and 30 can, right? And you can divide both of these by 5. So we get 1 on the bottom and we get 6 on top. All right, so then you get 1 times 1 on the bottom, which is just 1, that goes away. And then 9 times 6, all right, that's going to give you 54. And then you get 54 plus 32. All right, this is going to give you 86. All right, so we get a temperature of 86 degrees Fahrenheit. Now, that's something that we're more familiar with, right? But if we're given this formula up here, right, we don't know what to do, right? Let's say we were given 30 equals 5 over 9 times f minus 32, right? You can't really do much with that unless you get everything to the other side, right? And even with a quick Google search, right, this might be something that you've looked into before, right, for whatever reason, right? You notice that the two formulas have all the same components to it, and that's always going to be the case when you're solving literal equations, right? Every single component is still going to show up in your final answer no matter what variable you're solving for. All right, so hope this helps. I'll have a review video out shortly with some extra practice problems. Take care.